For it was their world, not man's. However he might shape it for his own purposes, it would be his duty always to safeguard the interests of its rightful owners. No one could tell what part they might have to play in the history of the universe. And when, as was one day inevitable, man himself came to the notice of yet higher races, he might well be judged by his behavior here on Mars.
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your hosts in England and Sweden, Matthew, Russell and Linn Boldt-Christmas.
Oh yeah, baby, Arthur C. Clarke. Right, back by popular demand, we have Linn. Linn, welcome back to the podcast.
Applause! Hello, thank you so much. I had so much fun, so I also shoehorned my way back in here, but I'm glad that the feeling was mutual.
Yeah, well, I hope this is super regular.
Me too. I've got a fancy microphone here now, so I might as well make the most of it, right?
Exactly. Well, you've got the best audio gear in town.
You know, last episode you mentioned you asked me what microphone it was, and I very confidently stated the wrong name of the microphone. And I don't now remember what it was, but it is a Sennheiser something. 441, I think. Yeah.
Isn't it got Elon Musk's name in it?
Like
Yeah, it's got something in it.
Yeah.
It's
Elon Musk gave it to me personally, actually, as a thank you for all my contributions to the world of space.
Oh, nice. I'm going to brag here, but I did teach Elon Musk's wife, Grimes, how to use her audio gear for live. I spent a couple of days with her.
Did you actually?
Yeah, no, I actually did, yeah. And I'd completely forgotten about it.
I made mine up.
I didn't even make mine up.
So.
No, I genuinely did.
Okay,
but I'd forgotten about it until I was.
That's so cool.
I was reminded. Yeah, it was really weird. Someone said, "I remember when you were teaching Grimes how to," and I went, "Oh my god, yeah." How weird. So so this is the final episode of our Mars month, because it's the last day of March when this comes out. So it's the last one, part 5. Managed to get 5 episodes in 1 month. It was quite good.
That is impressive. I must confess that I just in this very moment realized that that's why this is
all up
Mars. And you know what? In Swedish, it's actually called Mars. Like we do call it Mars. So yeah, I did not put those two together.
So it's actually so it's the Swedish for March is Mars.
It's Mars even, but I don't know if that's my disgusting Gothenburg accent butchering it. Maybe people in the north say Mars. I don't know, but it is spelled Mars.
Well, here we are. We're still in Mars month.
Still for now.
And we got to do a couple of science things because we've kind of neglected the science. So we're going to kick off,
sadly,
with why Mars is the way it is.
Why is it like
Why
that?
is it all cold and horrible?
Mars's very distinct red color actually comes from the presence of iron oxides in the dust. So the dust is basically rusty. So if you have ever thought, that's quite a rusty colored planet, that's because it's literally covered in rust. And one of the properties of iron that most people know is that it's quite magnetic, right? And the thing about Mars is that first of all, actually, let's go back. So our solar system, most of the things in our solar system, all basically formed at the same time. Because what happens when a solar system forms is that you have a star in the middle that gets formed because you have this big cloud, right? And these clouds are in space, and then to really simplify this, I know someone's going to now be pearl clutching, whatever the astronomical equivalent of pearl clutching is. So really simplified, you have a big cloud in space. This is how I tell it when I talk to 10-year-olds on Skype for Scientist. But you have a big cloud in space, and then the middle of the cloud gets really quite hot. You know, if you have 10 duvets on you and you feel like this is too many duvets and things get really hot. Well, basically the middle of the cloud gets really hot. And then it gets so hot that star formation is triggered. So what happens when stars form is that you just have these pockets inside interstellar clouds that reach a certain mass and pressure that triggers ignition. And then you start having fusion, and then voila, you have a beautiful star. But then you still have this cloud left over, right? You didn't actually shake off that cloud. So you have a young star with a bunch of cloud around it still. And that cloud is still sort of gravitationally bound to the star in the middle, right? And then, because the star that was formed in the middle has this sort of angular momentum, so it's like starts to spin, that cloud kind of gets whipped in to the sort of dance that it's doing. And a bit like when you toss a pizza dough in the air and it flattens out, the cloud then starts to sort of go around the equator of the sun, and then you start having this sort of disc-shaped cloud around it. Kind of like you can picture Saturn's rings, and you sort of have the same thing, that it's like the round thing in the middle, and then around sort of the equator, you have this flattened thing. That's basically what a young solar system looks like.
That's actually one of the best things about Saturn's rings, isn't it? Because we've learned loads about solar system formation from Saturn's rings, because it's like a sort of in miniature version. It's ace, isn't it? I love it.
Terrarium. Yeah. No, and that's the thing. And so you have these, and this is actually what I studied before I studied exoplanets. This was my topic, protoplanetary rings, or protoplanetary disks, which is just like a cool sci-fi word to throw into conversation casually if you ever need to.
PPDs.
Yes, exactly. So what happens is that you have this flat disk cloud, like a donut sort of, around a young star. And in that cloud, you start to get accretion. The cloud is made out of mostly hydrogen, but also rocks and ice and all this stuff. And it's a big thing that we're looking into now. There's a lot of active research going on, like how this accretion sort of happens. And what we do know is that you start to get these grooves in the disk. You can see if you look up, right now you have my permission to pause this podcast to go on Google Images and type in protoplanetary disks, either with a C or a K. That's still for people still argue about the spelling of disks. And then you can see that a lot of these disks have literal grooves, like gaps in the disk where we think planet formation is happening. But what that means is that you have all of the planets and asteroids and things, they all form out of the same leftover cloud disk. So they all kind of form around the same time. It wasn't like the sun was going, oh, Earth's pretty cute, I guess I'm going to make a smaller rusty version of it. It was like they were all kind of forming in tandem. So the age of the sun and the planets is also not that far apart, because this all happens pretty quickly as well. And
correct me if I'm wrong about this, that the cloud that it came from, this big massive dust cloud that started to spin round and become this disk, that was seeded by probably other stars that have blown up and put their elements into it. So it's not just this pristine material, it's material made already from nuclear furnaces all around the universe, right?
Yeah.
All around the galaxy, I should say, really.
Yeah, you literally just described my master's thesis, because that was the exact topic that I did it on. It was called The Ablation of Protoplanetary Disks Due to Supernova Remnants. And there are people actively researching what happens, like you said, you have this sort of mostly hydrogen cloud, and then you get a star in the middle of it. Horribly simplified. I'm so sorry for anyone listening to this. And then you get all of these rocky things or planetary things that form out of it. And then you're like, well, hold on. These things are way more chemically interesting than the cloud. Where did that come from? One of the big ideas is that you might have supernovas nearby that explode and projectile vomit a lot of metals into its neighbors, which could be us. Hello. And one of the things that strengthens that idea is the fact that because you have stars live in cycles, they have generations. You have stars that form and they grow up and then they die, and then they're all the inner guts that it spilled out in the form of planetary or interstellar dust is then drifting around, and then those clouds become new stars. And so you do talk about, the metallicity of stars and of these clouds. So yeah, there could be some in the cloud itself, but not really enough. So one of the ideas is that you could be getting injection from nearby supernovas, and because stars form in clusters, like you don't get one cloud equals one star, you do have multiple stars forming in a region together. Stellar nursery, I love that phrase, it's so cute. Because larger stars live for less time, then they could be die with such a timing that they could actually be exploding just as a new star is being formed. So then, yeah, there's some ideas about that. But anyway, Mars.
well, okay. So
to summarize,
Mars.
So
I think I know where you're going with this, right? So so we've got this planetary disk, which is pretty much made of the same material. But my question to you is, every time I make a pizza, because you've made me think of pizzas now, but every time I make a pizza, the dough actually comes out slightly differently, even though I'm kind of following the same recipe. But the planets seem to be a lot more different than the variation in my pizza cooking. So how on earth is why is Mercury so different to Venus, which is so different to Earth, which is so different to Mars? Really, why are Jupiter and Saturn and Neptune and Uranus and Pluto also different? And do the Kuiper Belt objects and the comets all come from this original protoplanetary disk?
Yeah. So they all come from the same disk. The structure of the disk is really complicated field. This is something that's still being determined. In a nutshell, first of all, it's flared. So if you're imagining it as a donut, imagine you're squishing down the inner circle and then the outer circle is like more tall, if that makes sense. It's a flared disk. The inner plane of the disk, the part that is like where the jam of the donut would be, so to speak, that part is very shielded compared to the rest of the disk. So the very, very inner plane of the disk is much colder than the outside, because at the surface of the disk, you have all this delicious radiation being burst out from the young star, the young host star. Because again, remember, we're talking about a disk. This is a stage that happens very early on in the star's life. We only see protoplanetary disks around quite young stars. So young stars also tend to be very temperamental, like a teenager. They're hurling their UV radiation, saying, "You're not my real mom," and stuff like that. And what happens is that then the outside, like exposed part of the disk is way hotter because it's being radiated. So you have this like very hot ionized stuff happening at the outside skin of the disk. And then as you go further into the disk, first it gets kind of warm, where it's sort of like molecular. You have a lot of interesting chemistry going on there. And then the very inner plane is where you have ices forming. So there's a huge temperature difference as well from what happens at the outside of the disk and the inside of the disk. And so this accretion thing, it happens in the inside of the disk where it's shielded from all this scary radiation. Then you have to think about what happens as you move further away from the star. So the disk part that is closer to the star is also hotter than what is further out. In our solar system, the rocky planets like Mars and like Venus and like Earth, they are all closer to the sun than the gas giants like Jupiter and Saturn and Neptune and all of them. So in our context, when we talk about planet formation in our solar system, we talk a lot about volatiles. So certain gases would maybe not survive at the temperatures that you find closer to the sun. But rocks, as we know, survive pretty well in hot climates. Read Mercury. So in our solar system, there's a correlation there.
Well, okay. Well, I've got a question for you then. So you've got the inner rocky planets, and that they've all formed, and of course, it's not. I guess it's not even that clear that they formed that close in, or that they've swapped places, and all those kind of crazy things that have gone on. But let's just assume that, say, Venus, Earth, and Mars were all pretty similar to start with, right? As in, they're three sister planets almost. Maybe two sisters and a little younger brother.
The little dumpling brother. Who's like, I guess you can come play football.
But talking about Venus is probably for another podcast, because obviously how Venus ends up like Venus ends up is obviously ludicrous. Yeah. But Mars is obviously now ridiculously different to Earth. But I mean, but people are always going on about how it was more similar to Earth. So what are the kind of really big shifts that have happened to make Mars drift away? Because I mean, even as even Carl Sagan thought there might be vegetation on Mars. That's how much the science has changed.
That's an endorsement. Yeah.
So it's like in our lifetimes, the science of Mars has well, certainly in my lifetime,
absolutely.
The science of Mars has changed. The thing that I've learned this month is that the Viking landers and when we first saw that Mars was just a barren wasteland, actually took the wind out of the sails of us wanting to go to Mars. Almost, it's a total desert world that's just useless. but I get the impression that people have started to think more and more about. No, actually, it's really exciting, and there's something really exciting about it because it's highly likely that it was like Earth in the past. So that's what's exciting about it.
Yeah. Mars our knowledge of Mars has, like you said, changed in even just like the last 5 or 10 years. Now we are saying, no, really, there was water on Mars once upon a time. That wasn't something that we were saying with confidence that long ago. And one of my favorite things to do when I talk to especially kids about space is to show them these pictures. Again, you have my second permission now. Go on Google Images and look up Mars riverbeds, because there are these amazing pictures. You can literally see it looks like a dried up river on Earth. We know what water looks like, and there was definitely something flowing. So the main thing that we think has changed with Mars, and this is very exciting because I actually found out that there was a new piece of research that came out like 2 weeks ago that shed new light on this. So let me first tell you what I would have said 2 weeks ago, which is that one of the main things that we have that protects us here on Earth is our beautiful magnetic field. It is like a bona fide Marvel-style force field that protects us, and we should be eternally grateful for it. Quick GCSE lesson, if you remember from when you were kids, you have convection in the core of the Earth. We have a bunch of sort of liquid iron, and we have a magnetic field that is generated from that. Do not ask me why, because I know even geologists are not 100% sure on this. But we have a magnetic field, and we're super grateful for it.
Do you know what? I think it must be one of the most fascinating areas of science, because when people start to describe what we know about the Earth's core now, and these giant iron crystals that are spinning around in the core, and you go, what? Yeah. Giant what?
And people are like...
and you go, and it's creating... and we're just like... And it creates the magnetic field, but occasionally it swaps, and there's all these, all the birds go mental.
It creates a magnetic field until it doesn't.
Yeah. Exactly. So why do they think that Mars is... Presumably Mars had the same mechanism at one point. It had a molten core.
So what we do know is that, like I said, there's a lot of iron on Mars. And like I said, iron is magnetic, and something that's so incredibly cool. Actually, I remember hearing this as a child and being like, I want to study planets, because one of the things they've realized with Mars is that if you look at the minerals on the rocks there, you can actually see that there is alignment with what would have been old field lines. So we do know that Mars had a magnetic field. There's several reasons for it, but we have good evidence. There was at some point a magnetic field around Mars. Was it as strong as as the Earth field? I don't know. Was it similar in other ways? I don't know. But there was definitely something that protected Mars. And the way that the magnetic field protects Earth is because you have these solar flares from the sun. The sun may no longer be a young star, but it still have temperamental flare-ups where it chucks out a bunch of radiation. And when you have these solar flares or solar winds, you have highly charged particles that strike Earth. And our magnetic field usually is able to repel all of those, and they sort of cascade around us and they don't bother us. Because of how the magnetic field lines work, we do have some of those particles that slide in, if you will, towards the poles, and then they interact with our atmosphere, and you get these beautiful lights called northern lights or southern lights. And we look up at that and we're like, oh, that's so cute. Second. But instead it's like...
So do you get... Are you able to see them from Sweden?
Absolutely, yeah, we get them here quite often.
So you've seen them? Do you actually? Is that like a sort of?
Yeah, beautiful.
Oh, so you've grown up with them. It's like a sort of
Well,
boring
actually,
phenomena for you.
Yeah. Oh, raining again. Some more aurora. No, actually, I haven't grown up with them because I was in the south of Sweden. We don't see them so much, but in the north, very much so. Just beautiful, and the different colors correspond to different molecules in our atmosphere. It's kind of like the mechanism that makes neon signs light. It's like I'm simplifying it, but it's more or less the same because it is about excitation, and we look up at that and we're like, oh, it's so beautiful. We're so, how pretty is that? I'm going to take a picture for Instagram. But it's like, if that wasn't there, we would be victims of horrible radiation from the sun all the time. So at some point, Mars had a magnetic field and now it doesn't. And until recently, one of the leading ideas with that, and I guess it's still an idea, but asterisk, I'm coming to that. One of the ideas is that when it lost its magnetic field, it no longer had that protection from radiation from the sun. And if you imagine that you have a atmosphere, I mean, atmospheres are gaseous, so they're not very well connected. Like, the only reason the atmosphere sticks to a planet is because of gravity. But it's not really tethered. So then this word ablation that I used earlier means when something is stripped away like this. So if you imagine that you have, if you are licking a soft serve ice cream, you are ablating that ice cream, basically. And so the solar flares were ablating the atmosphere. And one of the reasons for thinking that, amongst other reasons, was because Mars does have an atmosphere. It's just much thinner than Earth's, for instance. But there was a paper that came out recently that looked at maybe the water and the atmosphere didn't just ablate away. It could maybe have retreated into the crust itself. So maybe there is still some of that water, for instance, that is still in Mars, but sort of in the minerals. I'm not a geologist now, so I'm going to just say that because I don't know the exact chemical terminology for it. But that's something, my point is that this is something that's still ongoing. We're literally like in 2021 still trying to figure out ideas about it.
The bit that I don't understand is once you lose your magnetic field, what then stops the solar wind from just continually stripping off the atmosphere until there's nothing left?
Well, that's basically what it's been doing.
But Mars has got some atmosphere. As in, you can still slow us.
But for how long?
Yeah, well, that's it. So, is it actually depleting all the time? Is the atmosphere actually going? Are we going to eventually, in say 1 billion years, is Mars going to have no atmosphere?
I'm sure someone has run the numbers on that. Ablation from radiation is an ongoing problem for everyone, and the fact that we have our magnetic field, we're very grateful. Because it's not such a big problem.
Yeah, because I'm just trying to think if there's any sort of geological processes that replenish the atmosphere. Presumably the atmosphere came from somewhere in the first place.
Well, exactly. This is also why it's such a big question when we look. The reason we want to study exoplanetary atmospheres, for instance, is to figure out what is the spectrum of atmospheres in the universe, because then that can give us insight to where atmospheres like Earth's or Mars's, where that ranks. And there's so many cool things that can affect an atmosphere. There are also ideas about how atmospheres can be replenished and stuff, but it's all really baby science right now. It's something that has been studied in earnest, like in the last 10-ish years. So stay tuned.
It's really fascinating, actually, because the one thing that the phosphine debacle made you realise is even with our closest neighbour, with a great big thick atmosphere, we still don't really know much about it. And it's just like, so, and that's our nearest neighbour. So like looking at exoplanets and things like that. And I love that idea of ranking where Earth, Venus and Mars are in the atmosphere, you know, in the charts of the atmosphere. Because it could be, that Earth is just super freaky. It's a super freaky atmosphere.
Yeah, exactly. I mean, there's also so many factors. Like, if aliens looked at Earth, they would be like, yeah, nitrogen, oxygen, roughly 15 degrees. I mean, that doesn't tell the whole story. Think of all the different climates that we see on Earth and like all the variation from places to places. Like, you can travel tens of kilometers and have a totally different weather pattern. So the fact that we're looking at entire planets and we're like, it's basically 25 Kelvin. It's like, what?
It's a
Kelvin?
bit like watching an episode of David Attenborough's Life on Earth and thinking that you've seen all life on Earth, because in a way you go, it can't be more diverse than that, right? And then obviously he's had a lifetime of those programs, and he's probably he has only scratched the surface of life on Earth. And you think, wouldn't it be amazing if we found another planet which had life on it, and just how long it would take you to explore it? I mean,
let's just spin off space. Let's just go exploring on Earth.
Well, yeah, I mean,
guys,
but there's certainly plenty of exploring to do. I mean, you were sort of talking about rusty, the whole planet being rusty. Is there places on Earth that are rusty?
Yeah, I think so. I mean, so colors basically just come from different kinds of crystals. I mean, snow is technically a crystal. It's a water crystal. So there's such a huge... I actually nearly studied geology at university because I just love a good rock and a good bit of sand. And all of these beautiful colors, it's all just like different brands of copper and iron and stuff like that. If we've heard of it, it probably exists somewhere on Earth.
Actually, Britain's quite a good place to live for geology as well. There's a lot going on, particularly Devon. I walk around here, and the rocks are amazing. But the because we probably should start shifting this towards the second part of this, which is sample return, because presumably there's only so much science that we can do from here and with robots that tell us the story about Mars and how it lost its atmosphere. You know, what's the full story of it? How what's the sort of state of its atmosphere? What's the full state of things like that, and all these mysterious methane events that happen, and all those kind of things. And really, I guess the big news ever since Perseverance landed is that really that's the start. Perseverance is the start of this idea of sample return. And I guess, but before we get onto that, do you know the answer about whether sample return could, say, look at things like magnetic fields? As in, are these core samples, are they detailed enough to reveal things like the history of magnetic fields, do you know? Or would you have to dig deeper? They
would definitely give a good start. So the science that is able to be done with the robots on there, like they have these cool little stomachs that has all these cool science experiments that they do. And I mean, really, we're like sniffing rocks, scratching rocks, tasting rocks, just doing whatever we can to the rocks. But of course, there's a limited capacity in what the robot can do because it's a lab on wheels. So the benefit of having an actual sample return is that we can do so many more things. And because we can actually take, cut it into pieces and then do multiple things with it. As you know, launching things is a pretty expensive affair. So you're really never going to be launching a rover with more than absolutely necessary. So the kind of experiments that you're able to do with the soil samples that we get from there are very bare bones. And they've been a fantastic insight, but there's so much more we can do on labs on Earth. So honestly, even small samples would be such a massive step.
Yeah, because we do get natural samples, don't we? Like things like rocks that have come off Mars that have ended up hitting the Earth, and we occasionally find the odd Martian meteorite on Earth.
Yeah. But this is more like going to a restaurant instead of finding a hot dog in a garbage bin. So it's like...
Exactly. So obviously this has been on the cards, hasn't it, for a long time now, this idea of sample return. Yeah. And I thought...
Oh, fantasy.
I was reading about this and I didn't realise how far the kind of plans had got the time before, because NASA and ESA had been in talks before in 2006. There was the International Mars Architecture for the Return of Samples, or IMARS, the clever acronym. I don't know whether...
They're like, the kids like iPods, they'll like this.
IMARS. Right. Yeah, but that's before the iPod, isn't it? 2006.
Oh, wow. Maybe. Or just about.
So maybe NASA,
Maybe Steve Jobs was on that committee.
So, and they basically said that, yeah, we should go and do this in the 2018 to 2023 timeframe. So we would be sort of in the middle of that program now.
Right.
But basically, the NASA withdrew from ExoMars because of funding issues.
Boo.
Yeah, and I think it's mainly because James Webb was costing so much, I think.
Oh my God, James Webb. An absolute albatross around our necks. I love James Webb.
Well, yeah, I mean,
I love this telescope, so I'm not going to badmouth it.
Well,
I just want
exactly.
it to happen.
And it's of course the most stressful event at the end of the year, isn't it? Particularly for...
I can feel my heartbeat, my heart rate going up as we speak.
I feel especially sorry for Julio, who has to write the letters if it all goes wrong.
Oh God! I hope he's ready.
So, but the
no,
it won't happen.
It's okay.
As a European, I feel really responsible for the launch of. I don't know why. I'm taking the whole responsibility on my shoulders.
Oh my God! Yes, yeah.
But yeah, so they cancelled it. So the whole thing was cancelled. Apparently, pretty traumatic for the whole science community. A lot of development had gone in. There was this caching rover called Max C and all these kind of things, and so that got binned. Damn it, because you can see that a sample return would just be monumental.
Oh my God!
I've heard it described as the science is so big that it can change civilization.
It's monumental. So, absolutely.
So they've started again. So 2018 is the start of it. So NASA and ESA signed a letter of intent. And by July 2019, they'd kind of proposed some architecture to return samples to Earth by 2031. So a decade away. I know it's...
Oh, my heart. We were told it was going to be now.
Exactly. Well, I know. So
come on.
It's put it back 10 years, really, hasn't it? So 2031. Yeah. In April 2020 was the updated version of all this. And November 2020, NASA released this thing called the MSR, the Mars Sample Return Independent Review Board, or the IRB, basically gave it the green light and said, this actually looks like NASA and ESA are ready. This is really doable. And I guess they must have done that before, and it's like we weren't even close to being able to do it.
Guys, come on. Really?
But I think with the success of Curiosity's landing and the fact that now that's a way of getting stuff that big onto the surface. And now NASA have done it twice as well, the Sky Crane, and they've done it twice. So they don't, this new thing, they don't have to redevelop any way of getting hardware onto the surface of Mars. So that seems to be the breakthrough. Yeah,
that's exactly what I was going to say. And as someone who has been on both sides of enthusiastic civilian science dork who just really wants to see the missions push through, and also having worked in the field, and it's never as easy as it reads in a headline. I mean, people are like, oh, if there was a budget problem, just cut this other thing. But it's like, it's never something straightforward. And the good thing about our industry is that you are never truly starting from scratch. Even if something gets far and gets cut, that doesn't mean that you've lost that work, because when you have opportunities down the line to recreate or turn that into something else, you are building on that foundation. So I'm sure they're not starting from nothing. It's sad that it got delayed, but you know what? They just weren't ready, and that's okay. And we're here to support you, NASA. If you need a call, just have a chat. I'll hold your hand.
I mean, it's super exciting. It makes you realise how difficult this thing is, because the guy, one of the people on the review board, David Thompson, gave 44 recommendations to address potential areas of concern. And
that's translation is massive.
These are massive issues, and they're always surprising. And things like the management how do you manage a project like that when you've got the Europeans and you've got the Americans and you need to be able to talk to each other? You've got the Italians doing some bit, the British doing some bit, the Germans doing another bit.
Yes.
And it's like, yes, these are like, just as a management, as a project management thing, it's very ambitious. But technically it's ambitious, and funding-wise it's obviously mega ambitious, because when we describe this mission, you'll realise just how difficult it is. So I wanted to do a quote by David Thompson, and it goes like this: "The MSR campaign is a highly ambitious, technically demanding, and multifaceted planetary exploration program with extraordinary scientific potential for world-changing discoveries." So it's
brilliant accent, by the way.
It's so it's big. It's basically saying this is going to be insanely difficult, but the payoff is so big. It's got to be worth it.
Yeah, subtitles is, guys, come on.
come on. Let's do this.
Come on. It would be so cool.
Oh my God.
That's the thing. And something I love about scientists and people who work in this field as well is that, like, you can always just count on people to geek out so hard. And it doesn't really matter what it is. And it's like, if you keep pushing it, people will give these very eloquent, insightful replies about motivation beyond for, scientific objectives and stuff. But if you keep pushing it, it's like, it would just be really cool. And I want to do it. And it would be really cool.
Yeah, I mean, what's incredible is that we'll get the samples back in 2031. And that's if everything goes to plan. And you know what space missions are like.
Yeah. So that's 2045.
And then there's people thinking that we're going to have humans on Mars before the 2030s. Just not going to happen, is it?
Oh, no.
I mean, let's be...
Honestly, well... And that's another cool thing that's another relevant point about the magnetic field. When because I do a lot of outreach, I talk a lot to kids, and one of the really common things, I guess they've been watching a lot of Elon Musk interviews, they ask, like, when are we going to move to another planet, kind of thing. And I always love to burst their bubble by explaining exactly in all the ways in which that's really difficult. But one of the things, magnetic fields is a big thing. Like, if you're gonna live on a planet, how are you gonna deal with intermittent, horrible radiation? You have to think about gravity. That's something that you can't just tinker with. Like, if you want to be on a planet that has crushing surface gravity, that's not gonna be fun. There's just, like, beyond just the logistic nightmare that comes with that, there's also so many problems with the planet itself. And I mean, Mars it's better than Venus, but not by much to live on.
Yeah.
It's like still not good. I mean, plan A should really be fix climate change on Earth, please.
Yeah, I mean, absolutely. But thankfully, it's not an either or question, is it? I mean,
exactly.
And I actually do think that there is, that discovery of Venus's climate and Mars's climate is like, hey, look, when you're in the solar system, your climate can radically change, by the way, and it's due. So and
then that's it.
But what's brilliant about this plan is you can kind of see it starting to come together. You can see how they're going to do it, but. You mentioned the gravity and the kind of conditions on Mars, and one of the hardest bits of this. Well, let's get to it. So you got Perseverance that's on the surface now, and it's different to Curiosity in the fact that it can drill and core and put them in these pristine, and I say pristine, like caching tubes, right? They are apparently they are the cleanest things that have ever been sent into space.
Beautiful.
Into space, yeah. So these are that's it. They're the cleanest thing ever because they can't be contaminated. Because you can imagine how irritating it would be if you got
guys, there's a piece of moss on Mars.
Oh my God,
wait,
there's tardigrades on Mars. No, I think they just might have just.
There's a hot dog in here.
I think hopefully they've cleaned it better than hot dog sized material. But yeah, it's the cleanest hardware ever sent to space, and it's there. You know, that is there. So there's kind of three parts to this, and we've already got the first part done, and that's getting Perseverance on the land.
Check.
Tick. Second part, which apparently is to launch in July 2026, is the Mars Ascent vehicle, which will be developed by NASA. And on board of that will be a sample collection rover built by ESA, which I believe is Airbus, isn't it? That's developing that.
I think so.
Of course they've built the Exomars rover, the Franklin, the Rosalind Franklin. So that lands near. Yeah. That lands actually near Mars 2020 because it's going to follow its tracks and pick up all the.
Got a sample for me.
Pick up all the little sample tubes that it's dropped. And actually, Perseverance, apparently, if it's still running by then, which is kind of like 2028 by the time this thing has landed and started to.
But I mean, old rovers. Have lasted.
I think it will be still running by then. Yeah.
Totally
absolutely
feasible. Like disaster aside.
So it will help actually. So it too might actually go around picking up its old canisters, bringing them back to the Mars Ascent rocket, which basically the lander has this rocket on board.
So cool.
And I think this is probably must be the hardest bit, mustn't it? Launching a rocket.
I think so.
From another planet.
Launching a rocket is hard, full stop.
But launching a rocket that's landed on the ground and then launching it from another planet with different gravity. So it's not like this thing can be tested particularly easily.
No. And it's so many moving parts. Like I can hear the Wallace and Gromit music in my head in the background. Like there's just going to be so many things that could go, so many points of failure or potential points of failure.
But this is my favourite bit is so that this two-stage rocket, it's not just like a sort of like a thing that spits it out. This is quite a big two-stage rocket that carries the canister up into Mars orbit.
Holy moly.
Now, hopefully that gets into Mars orbit by 2029. So it's there. It's this tiny little metal ball with all the canisters in. Is in orbit around.
The most precious cargo.
Super precious cargo. Is in orbit around Mars.
Oh my gosh.
But a few years before, 3 years before, an Ariane 6 booster will have hopefully launched an Earth return orbiter. So ESA have built that, and that's going to by the time the canister's in orbit, hopefully the Earth return orbiter has arrived at Mars a couple of years before and slowly lowers its orbit using ion thrusters.
Yeah.
So by the time it gets to 2029, in fact, it's going to get into the right place before the canister's launched. But hopefully there'll be enough time that it can go round and find this metal canister and pick it up and then by 2031 come back on that transfer window back to Earth, and then it's going to spit it out. It's going to go re-enter Earth and land on Earth in 2031,
and then smash in a million pieces at the last second.
We'll get this. So there's a couple of things that are really interesting about that because of this need for planetary protection. Even if, like the heat shield of the canister, they're going to make it so strong that even if it was to just smash into the ground at terminal velocity, it wouldn't break open. So it would, like, obviously,
I'm okay. It would be horrible.
It'd be a massive mess, but it wouldn't release the samples out into the wild because, of course, there is actually a tiny, and I think it's a tiny risk, but there are some people that I hadn't realised that there is the International Committee Against Mars Sample Return, or the ICAM-SR. Yeah.
What?
So this is yes.
Excuse me?
This is led by Barry Di Gregorio. He's a bit of a crank, actually, Di Gregorio, by the looks of things.
Barry the crank.
He believes in the conspiracy theory that NASA are covering up that they discovered microbial life on the Viking landers.
That old chestnut.
But he runs this the International Committee Against Mars Sample Return, saying that he's not against sample return, but he's saying that we haven't done enough when it comes to the biohazard of this stuff coming back.
What's the worst? What's the worst that can happen? We have a pandemic? Come on.
Well, yes, no,
Come on.
well, absolutely. I mean, talking of cranks, but probably a more famous one,
Yeah.
Robert Zubrin, of course, argues that pretty much the chance of contamination is functionally zero. Because even
right,
yeah,
I would
even if
agree.
you had bacteria or viruses in the Martian soil, because they have a different origin, they almost certainly wouldn't interact with the human body or life on Earth.
First of all, ding dong, jackpot, we found freaking microbial life. I'll take that hazard. And second of all, yeah, I mean, if you want a contamination to happen anywhere, surely it should be in the hands of the scientists who are paying a lot of attention to what the thing they're looking at is.
Yeah,
I mean,
well, they're going to build.
I think they would notice pretty quickly and pretty much quarantine that immediately.
NASA are building a biosafety level 4 containment facility called the MSRRF, the Mars Sample Return Receiving Facility.
Such catchy acronyms.
The rubbish. That's actually, they must be able to make Mars out of that somewhere, but it's Musarraf,
Yeah, exactly.
which is pretty annoying. So, yeah, I thought that was really interesting that yes, this thing could. The actual capsule could re-enter, smash into the ground, and still actually be all right.
That's really cool. I didn't know that.
Yeah, I mean, I wonder.
I mean, that's one hazard reduced. Only 8,000 more to go.
Well, we know there's at least 44 areas of concern, which is good.
Exactly.
But yeah, I think it's. There is a sort of second element to this that's very cool that we probably should really mention, and that's the fact that if you're able to do this architecture of getting something onto the ground, getting it back and getting it back to Earth, of course, the lessons learned there do help with thinking about doing the same with humans. Oh,
absolutely. In space, you're never really starting from scratch. You're always building on previous knowledge. Everything in human space exploration so far has been building blocks of going from empty vessels to monkeys and dogs and cats and humans. And this would absolutely just be one of those stepping stones.
Although, saying that, one interesting thing that came out of our interview with Gary Martin was that he mentioned that he was the NASA architect at the time, the one and only, the first and only NASA architect. And he was against the sky crane.
Oh, really?
Because it could never be used for human landing.
Huh.
And so the lessons you're learning there aren't particularly useful further down the line. They're great for getting 1-ton objects on the floor, but not 30-ton objects.
I see that logic.
Yeah, I thought it was really interesting.
I thought,
after watching Perseverance land and going, oh, it's the most amazing thing ever, and then actually hearing that someone
was like, I hate it. Get rid of it.
of note going, I tried to get rid of the thing. It's rubbish. No, I mean he obviously was saying how amazing it was, but the fact was it was he was against it at the time because it didn't help with the overall architecture.
Yeah, and that is interesting. I mean that is kind of the mindset you have to be in space projects for sure.
That's long-term thinking.
Outside the box, beyond the horizon. Speaking of project management in the space industry, if any of our listeners are young professionals in the space industry, so under the age of 35 and working at one of the IAF affiliated organizations, there is actually a young professionals workshop that is currently open for applications, where you would be put in a workshop with fellow young professionals and talk about project management and do a workshop on that with myself as well. So, I don't know if that's a selling point.
There's so many reasons why I can't go. I'm not affiliated with the IAF, and I'm definitely not under 35. God damn it. But I know there's a lot of people out there that are. And that's where you met.
I have met Harriet. Yes, both me and Harriet are alumni of that. So if you're curious, you can look up, are you ready for this very catchy acronym? The IAF IPMCYP workshop. Yep. Speaking of acronyms.
and just think, once you've done it, you might have the chance of one day being a host on the Interplanetary
That
podcast.
is where you're recruiting hosts, right?
That's as good as it gets in the space
I think
industry.
so.
Apart from being an astronaut on your way to
Oh my God,
Mars.
I would hate to be an astronaut. Can I just tell you? I do not want to be an astronaut. If anybody wants to encourage me to be an astronaut, throw yourself against the wall. I don't want to do it. Please leave me alone. I like my bed. I like my life. I don't want to go to space. And it breaks my heart. I have little kids ask me this sometimes, and they're like, do you want to go to space? And I'm like, no, that's for brave kids, and I'm not one.
I think I could get over all the kind of discomfort just for the
bragging rights.
Well, yeah, and for the bragging
rights.
rights. I mean, let's face it. Yeah, going into space is.
So would you sign up on a one-way trip?
A one-way trip to Mars. If I was a little bit older, yeah.
Guaranteed name in the iron oxide stone engraving, like certified.
Do you know what? I think I'd certainly do it if it was the first trip there.
Yeah?
Well, because you are then immortalized,
forever.
aren't you? It's like,
yeah.
I always think that Neil Armstrong and Yuri Gagarin, for example, will always be famous because you can never take that achievement away.
Right, you can never.
That's it. You can never be the first anymore.
It's never irrelevant.
So they're potentially famous for the rest of humanity.
Yeah.
Even if we were this multi-planetary species, the name Armstrong and the name Gagarin would come up.
That's true.
Do you know what? I'm telling you what's exciting. It's the 60th anniversary of Yuri Gagarin coming up soon.
That's true. That's true.
Well, thanks very much for joining me again, Lynn.
Thank you so much.
Back by popular demand.
Woo!
And rightly so.
And now they're going to be like, never invite her ever again.
Yeah. Well, I gave her a second chance. She still blew it. Right. So if you liked the episode or liked any episode, you can go to interplanetary.org.uk, see the show notes and link out to all our social media. I mainly do Twitter these days. My Instagram's gone a little bit off the boil because I'm just too busy.
I'm the worst
to do with pictures.
I'm the worst millennial ever. I have nothing like that. I just have Twitter because I can look myself in the eye and be like, it's okay. It's for networking, not procrastinating. Brackets, it's for procrastinating. So.
Yeah. Oh my God. Yeah. I mean, my social media just is the unbelievable waste of time that I literally can't afford to do right now. And if you've enjoyed it especially loads, you can go to patreon.com/interplanetary. That's it.
Yay!
Bye bye, Spudheads.